Application layer, considered to be the user interface responsible for taking inputs and displaying received information to the user. For example, using the browser to open a website, the browser will form an application layer HTTP request. Example of protocols that operates in the application layer are HTTP, HTTPS, FTP, DNS and DHCP. Presentation layer operates as translation layer, which takes the data from the application layer or from the lower layers and perform translation operations. For example, translating from alphabet characters to ASCII, perform encryption, decryption and compression. Session layer manage sessions restoration, authentication and authorization between end-user application sessions. For example, data received for a chat application with multiple chat windows opened will be handled by the session layer to be mapped to the correct chat window. Example of application layer protocols: L2TP, PPTP, PAP and NetBIOS. Transport layer. In the transport layer, the OS will define the transport protocol, whether TCP or UDP, and add the source and destination port numbers. Then the transport header will be added. The source port number will be added to a random port higher than 1023, and the destination port will be defined according to the application being used. In our example, we are using HTTP. The transport protocol will be TCP and destination port will be 80. If we are using DNS, then the transport protocol will be UDP and the destination port number is 53. Network layer. Network header will be added to the data, which includes the source IP and destination IP addresses. By determining the destination IP, the OS will check whether the destination IP is within its own network. Then the packet will be forwarded directly to the destination hoster within a remote network. Then the packet will be forwarded to the system's default gateway. In our example, the destination host 192.168.2.2 is not within the source host network 192.168.1.0/24, so the packet shall be forwarded to the network's assigned default gateway 192.168.1.1. Data link. L2 header will be added, which includes the source and destination MAC addresses for the Ethernet network. The source MAC address will be source host interface MAC address, and the destination MAC address will be determined by sending up resolution to the next hop host. In our example, the frame will include the host's source MAC address AA and the destination MAC address of the default gateway BB, because the packet destination IP address is not within the same network as determined in the network layer. The physical layer is responsible of the modulation of the data packet into bits on the medium. This could be an electrical signal on a copper wire, a laser beam on a fiber optics. Once the switch receives the packet, it will check the destination MAC address in the data link header. Search the local CAM table for the port which is connected to a device with MAC address BB and forward the frame out of this port. In this example it is PA2. Once the packet has been received, router will check the destination IP address, which is 192.168.2.2 in our example. The router will look up in the routing table for the network entry match destination IP address 192.168.2.2, which is the network 192.168.2.0/24 in our example. The network indirectly connected to interface Ethernet 1. The router will swap source and destination MAC addresses with the new ones and forward the packet.